We did it. We're live. Hey, everybody. How is your evening, morning? I guess it's the whole world, circular world, so I guess people could be seeing this at all kinds of times. But for me, it's early evening. What a day. What a week. What a month. What a year. But we're plugging along. Okay, so if you have never done this before, this is my live question show. This is what turns into the QAs. So if you have some questions about space and astronomy, about any topic that pops in your head, just go ahead and type your questions live. And then Nancy is in the chat, and she will push your questions into a special dashboard that I can see. And we'll answer your questions here. And as always, I've got a bunch of prepared questions that were asked on the YouTube comments. So I'll get to those first, and then we'll shift over and go into your questions. And then stick around because I wrap the recorded portion up about the end of the hour mark, but then I stick around and we call this overtime, and I'll answer more questions kind of in real time as the chat is going on. So even when I sort of wrap up the show, I'm not actually wrapping up the show. It's about another usually 20 minutes or so after that. So, okay. Just gonna have a drink of my space water. My God, it's full of stars. Okay. Live. And start the recording. Start the other recording. Okay. Hello, Chad. Here's your recording, your audio and video. Yes, I am recording. Okay. Hey, everyone. Welcome to the question show. Your questions, my answers, as always, wherever you are across my channel. If a question pops into your brain, just write it down, gather them up, and I'll answer them here. I just want to give sort of a reminder that, people ask me like how they can support, how they can help out what we're doing with Universe Today. And Universe Today isn't just me. It's a giant team of writers. Most of our energy is spent writing articles over on the Universe Today website, but also recording the podcast versions of everything we do, as well as doing the YouTube videos and a lot of other projects. So the best way to participate in that is to join our Patreon. And if you've been enjoying our content for years, maybe decades, because we've been doing this for 20 years, and you're feeling a little guilty and you have some money to spare, then join the Patreon. Go to patreon.com/universetoday, and you get an ad-free version of the website, which looks much nicer. You get sort of more behind-the-scenes stuff. Sometimes you get some ads in advance, but you also know that you're helping to create the content that we are working on. And it allows us to be completely independent, not beholden to any grants or investors or anything. We're just doing this for you. And you can even just sign up for Patreon for 1 month, cancel right away, and you'll still get the ad-free version for the rest of your life. That's how little ad revenue we make. That, if you donate $3 through Patreon for 1 month, no ads for the rest of your life. So if you're feeling guilty, you're feeling like you really need to support what we're doing, go to patreon.com/universetoday. All right, let's get into the questions. Simba, how do we know that light is red or blue shifted? How do we know that it wasn't its current color all along? How do we know it used to be a different color? So astronomers talk about this idea of red shift or blue shift, and essentially it falls into this idea of the Doppler shift. And I'm sure you know this experience, right? When an ambulance is driving towards you, you hear one sort of sound, and then as the ambulance goes the other past you, then the tone changes, or like a horn, as they go past, right? And that is just the sound waves as they're moving towards you. They're bunching up, and you're experiencing them at a higher frequency. And then as they're driving away from you, you're experiencing the sound waves less frequently, and it sounds like a low frequency. And it's the same situation with light. And so if the object that is emanating the light is moving towards you, then the frequency of the light shifts towards the blue end of the spectrum. And if the object is moving away from you, then the frequency shifts towards the red end of the spectrum. And I guess the question is, like, if you see something that is blue, how do you know that it used to be red? How do we know that it's not just blue and it just is just a blue star? And so astronomers use this technique called spectroscopy. And what they do is essentially they look at the light from any object. You look at a fire, you can look at the sun, you can look at a light bulb, anything. And you then put it through a spectrum. And so the light gets expanded out and you get that rainbow. But the rainbow for different kinds of objects changes depending on the chemicals that are in it. And so you'll get these little lines inside of it, darkened areas where various wavelengths are sort of able to be identified throughout that entire spectrum. And so astronomers, or chemists really, have gone and taken pretty much every element that they know of, burned it, let me think. Burned it, shot it with a laser, done everything they can to get it to give off light. And what you get is this very specific chemical fingerprint. And so then astronomers will look at the light coming from some object, say a star that's moving towards us. They can see where the lines, they see the fingerprint, but they see that the fingerprint is shifted over slightly, or shifted over the other way slightly. And from that, they're then able to tell essentially how much that light has been shifted to the red or to the blue. And then they're able to use that to determine the velocity of the star or galaxy or whatever coming towards us or going away from us. Okay. Louise Velasquez. Fraser, future video idea. Can you do a comprehensive review of Starlink, especially with use from North America? If you've already done one, I missed it, I would love the link. I'm not sure I would ever want to do a comprehensive review of Starlink. So for those of you who don't know, I live now in the Canadian forest, fairly far away from the town that I used to live in, and there's no way to get a wired internet connection to where I am. It would cost like $1 million to convince the telcos to run the line all the way out to where we live. And so I had to go with satellite internet, and the traditional satellite internet is terrible, but Starlink is pretty good. I'm sitting here recording this show right now in the back of a trailer, connected up with a router to my Starlink terminal, which is sitting outside, just sort of on a hill with a clear view of the sky. So what's it like living with Starlink? I would say it's effortless. Like almost all the time, it feels like we had a broadband internet connection. It's not quite as fast. And so if I'm like downloading like really big video files as we're like working with sending files back and forth with me and Chad, it's a little slower, but in many cases sort of it's fast enough. And then it's like the internet websites are the bottleneck and the bandwidth problems. I've been playing video games. I play like Path of Exile. And so the ping times are When it's working perfectly, the ping times are about 35 milliseconds, which is fine, which is good enough for me to be able to play the game. I probably wouldn't be able to play a competitive game against other people, but I do get lag spikes and they kill me. And so my guy dies and I'm like, oh, lag. So, but most of the time, you know, if we're just like watching TV shows or I'm doing research for Universe Today and uploading video and that kind of thing, you don't notice the lag. You don't notice the download, upload speeds. It's all pretty effortless. In terms of like maintenance, you know, it's fairly power hungry. We needed to get power here before we could really run the dish. We were able to run it a little bit when we would like turn on our car and our car has an outlet in it. We could run the Starlink for a little while and download all the, you know, download our TV shows and stuff and then turn it back off again. But now we've got power, and so we're able to just run it. Sometimes it will, you know, if we get sleet, like snow, it seems to melt off of it pretty well. One time we had sleet come down and got like this much like ice rain on top of it, and it definitely knocked it out. And so I had to go out and clean it off. But apart from that, you know, it's gone down twice in my time of using it now for more than a year. Went down for the longest was about an hour, and for like everyone on the entire Earth. So, you know, it's pretty expensive. I pay about $110 a month, which is about the same price that I was paying for my wired connection, but my wired connection was ridiculous. It was like, you know, gigabit internet, and now I've only got, say, 200 megabit internet. But I would say if you live outside of a city and you need internet and you can't get it from, you know, a wired connection, there's no better solution than Starlink. So that is my sort of user review of it. My astronomer opinion of it is less good, but we can save that for another day. Douglas Williamson. Why isn't the atmosphere of Venus a production... Douglas Williamson. Why isn't the atmosphere of Venus a productive place for humans to visit and colonize? Well, I mean, just trying to live in the air is really tricky. Like if you think it's hard to go to a place like Antarctica or Mars, where the conditions are really bad, all you've got to work with on Venus is the air. Because if you go down to the surface of Venus, obviously you will die. It's incredibly hot, incredible atmospheric density. It rains sulfuric acid. It's a very bad day. But if you go up into the higher atmospheric levels, you get to a point where the temperature and the pressure are kind of Earth-like. And in fact, the air that you would use to breathe would be a lifting gas. You could live in a balloon that is your air and float around in the cloud tops of Venus. But there's no other resources that you could grab. Like, you wouldn't be able to get any metal or any rock or anything really, that only what you could pull directly out of the atmosphere. But it's still a really massive gravity well. And so if you go down into the gravity well of Venus and maybe you're floating around and you want to fly out, well, you still need the same amount of rocket fuel to get out of the gravity well of Venus as you need to get out of the gravity well of Earth. And yet Earth has, you know, metal to build rockets. And so it would be really hard to build your rockets in situ, build anything on Venus in situ, like in place. You would need to bring everything. And so imagine what it would take to launch a rocket from Earth that's carrying a rocket capable of launching from Venus, so you could even leave the atmosphere of Venus again once you're there. So there's just a million reasons why Venus is terrible, and we'll only be sending robots to Venus for a very, very long time. And I know there's like cool videos of like people flying around in blimps on Venus, but like maybe I can't even imagine a reason why you wouldn't just send a robot. There's like no reason to send a person to Venus at all. Like, you can't even do geology. You can't even like go down and pick up a rock and lick it, which geologists like to do. Nothing. You're just sitting there staring out the cloud tops, flying your little dirigible. It doesn't make sense. So why isn't the atmosphere of Venus? Because it's terrible. It's terrible. There's nothing to do. Texas Vet, I'd love to hear your theory on how Hoag's object formed the way it did. I don't really have an opinion. I'm a journalist, not an astronomer. All right. J4H3AD. Simple question. What's your favorite thing about what you do? So I guess you're like saying like, what's my favorite thing about being a space and astronomy website publisher? Man, there's so many things that I enjoy about my job. Like, I don't know if people know my history too much, but before I started Universe Today, I was a tech entrepreneur. I worked at a couple of high-tech startups in Vancouver and went the whole venture capitalist route, leading fairly large teams, working with corporate clients, and hated it. Hated every part of it. I hated being beholden to investors. I hated having to work for clients, and I would have really good ideas and they would tell me that they didn't want to do them. And I didn't like managing a big team to the point that there was a lot of like politics and things like that brewing. And so as I was starting to work and build Universe Today, really on the side while I was doing my main job, my goal was to build an environment that matched my personality. So gave me freedom in terms of the time that I worked, the days that I worked. Let me work on projects that I find really interesting. Let me use my capability directly, so if I think of a new thing that we want to add to Universe Today, it's a very quick meeting. I meet in my mind and we agree that it's a good idea and we go ahead. I wanted to make an environment for the team that works with me that was like really positive and really effortless for them and sort of a joy to work with me and the rest of the people on the team. And so I think that's it. I think for me, the thing I love the best is just having the freedom to run the kind of organization that I would want to work for. And, the fact that I happen to work on space and astronomy is fortunate. I love the field, but it's more about building an environment that I really enjoy. Paul CH52, how do we know it's a type 1a supernova? Okay. Yeah, I'm not sure I can give you a great... So, Paul, how do we know it's a type 1a supernova? What in the spectrum is a unique identifier? I don't know the specifics, like exactly what they are, but essentially a type 1a supernova gives off a very specific signature in terms of the amount of time that it explodes in, the various chemicals that are given off as the star is exploding. So, I could do more research into it or bring on someone who's an expert in supernovae and we could talk about what are the characteristics, but there are very specific characteristics that tell astronomers that it's a type 1a supernova versus a type 2, for example. Chris Van Zegeren. Hey Fraser, how do you determine when something is standing still in the universe, when it experiences the least amount of time dilation? That's a trick question, because the whole way that time dilation works is that everything is in relation to everything else. So if you and someone halfway across the solar system happen to be moving in such a way that your distance, the difference in your speed is very low, then you're going to experience very little time dilation. But the farther away you go, between you and someone else, now you're moving apart at faster and faster rates. And so you're going to be experiencing different amounts of time dilation. And so there's no place in the universe that is not moving. Like if you take one side of the universe and another side of the universe, there's about a 60,000 year difference in experienced time just through time dilation. And you're just going to have various versions of that. So the place that is the least amount of time dilation is the person who's right beside you. Now, is there a place in the universe that isn't moving? And the answer is kind of no. But our Milky Way is kind of moving, or our local group is sort of moving compared to the cosmic microwave background radiation in a certain speed. And that's just through the motion of the galaxy compared to this sphere of cosmic microwave background that's constantly blasting at us. But it's not actually like the middle of the universe or a point of no motion or minimum motion. So there's no place. Fernando Rodriguez. Why do scientists at the NASA website and other resources insist that the sun is an average star when 85% of the stars in the universe are brown dwarfs, which are way small? You're not going to do this again because it should be red dwarfs, but sure. Fernando Rodriguez. Why do scientists at NASA website and other resources insist that the sun is an average star when 85% of the stars in the universe are red dwarfs, which are way smaller than the sun? It's a good question. I feel like it's a habit. Like the sun is just an average star, and the solar system is just an average solar system. And the Earth is just an average planet, and you're not special. It's like the Copernican principle that we don't exist in any special part of the universe at any special time, that everywhere else in the universe is kind of roughly the same as where we are. The laws of physics are going to be the same. The amount of matter, the kinds of stars, the amount of planets, the size of galaxies, as far as you go in all directions, everything is roughly the same. But of course, Earth is very special to us, but in the grand scheme of things for the universe, we're not special. But there's nothing super extreme about the sun, so maybe that's where they're getting this from. But you're right. The vast majority of main sequence stars are red dwarfs. And main sequence yellow stars, or G2 stars, like the sun, are less common. And then really giant stars are even less common. So I don't know. I think it's just they're just saying not like it is exactly down. If you take all of the stars and the mass across the entire universe and you average them out and the sun is right in the middle, it's not like that. It's just there's nothing weird about the sun compared to any other star. OMG Poopy. What effect do the current sanctions on Russia have on space exploration in the future? This is still an unfolding story, and I'm going to give you some high-level ideas, but my good friend Dr. Pamela Gay and the team at Daily Space just did a really comprehensive episode about all of the implications for the war and what impact that's going to have on space exploration just in general. But I can give you just a few examples. And it's not necessarily sanctions, although in some cases it's sanctions. But so you've got the Atlas rocket uses Russian-built engines, and eventually they're going to run out. Now, Atlas has enough of those engines to be able to launch their remaining payloads. The Cygnus cargo vessel launches on a similar platform that uses Russian engines, and that's going to be a bit of a problem. They're going to need to come up with a new booster stage that's going to be able to launch the Cygnus up to the International Space Station. And the Cygnus is kind of special in the way that its thruster configuration is. It's very good at helping to give the International Space Station a boost. That said, SpaceX has said that they can fill in the gap with Cygnus, both in providing cargo, but also in helping to boost the space station. But we'll see about that. The head of the Russian Space Agency posted like a really weird video where, like, with really nationalistic music, showing how the Russian segment of the space station could detach from the rest of the station and fly off for action and adventure. But it has very small solar panels, and how would it be resupplied? And there's all kinds of issues, but it could be possible that the International Space Station has to shorten its timeline significantly. The European Space Agency's ExoMars mission is a collaboration between the European Space Agency and the Russian Space Agency, and the rocket and the descent vehicle were all going to be done by the Russian Space Agency. So for the ExoMars mission, it's definitely going to be delayed. It's not going to launch in 2022. Maybe it'll launch in 2024 if things can be patched up. Otherwise, big chunks of that mission are going to have to be rebuilt. All of the Russian launch team members down at the European Space Agency's launch facility in South America have left. And so they're not there to support any Russian launches, which aren't going to be happening. We've seen OneWeb has had its rocket mission canceled, and now it's going to have to find a new launch provider to send up its satellites. There's a Russian mission called Spectre. That's like let me do this again. So there's a Russian mission that has a German instrument on board, and the Germans have decided to turn off the instrument. And so now they're no longer receiving science data from this instrument. So these are just like a few of the implications so far, but we're going to see a lot more implications as if this drags out. And it's really heartbreaking for me because, if you've watched a bunch of these episodes, I've said this many times in the past that I love the fact that the Russians and the Americans came together to build the International Space Station with support from the European Space Agency and the Japanese Space Agency and the Canadians, that it really is an international space station. And people from many different nations go up to the station and they hang out and they have a good time. That American astronauts learn Russian and they train at the Baikonur, they train at Star City in Moscow, and then they launch from the Baikonur Cosmodrome on a Soyuz rocket. Not anymore though. Now they can launch from SpaceX. So it's the end of an era, and it feels like there were grievances simmering below the surface that have now come to light, and we're going to be experiencing the ramifications of this for a decade. MNENG. I see that the U.S. military will be patrolling cislunar space. That should be good for space technology development, but also will advance the militarization of space. Not good. Thoughts? So this is based on a story that came out in the last couple of days about the plans for U.S. Space Force to send a patrol that's going to go around the moon. And I'm sure in your mind, you're imagining this space battleship that's going to be heading out from Earth and flying around the moon on patrol, but that's not what it's going to be. It's going to be like a satellite that has the capability to detect other satellites in the region and report information back to see if there's anything going on happening on the surface of the moon that maybe we're not aware of. But right now, like anything that's going to the moon has to launch from Earth, and the trajectories are very well known. So I wouldn't be super concerned. There's literally no military use of the moon. It's so far away. Like, yes, there is a military use of space, but it's really low Earth orbit and geostationary orbit. And once you get out to the moon, there's nothing out there to protect. There's nothing out there to patrol. And so it just like, it sounds more like them just developing an interesting mission that's going to allow them to test out further capabilities. And I wouldn't be too worried about it until there's like anything on the moon that is worth protecting, a base, a station, whatever, or multiple bases and stations. Like go and see For All Mankind. And they've got this future where there's like a base on the moon for the US and a base on the moon for the Russians. And there are various tensions that go on. And then it would start to make sense to have some kind of military presence out at the moon. But for now, no. Do I have problems with cats sleeping on on my Starlink? No, but boy, if we did, it would be cougars. So hopefully that never comes up. Liquid Flames. Any advice for an aspiring writer? Sure. You're not going to like it. Write a lot. That's my advice. It's like any advice for an aspiring plumber. Plumb a lot, and you'll get better at it. Learning to write is just a skill. It's a practice, and you have to do a lot of it. When I started my writing career more than 20 years ago, I was really good friends with a writer, a guy named Nigel Findlay, and he was a professional writer. And so he would write a lot of, like, if you play role-playing games, you play like Dungeons and Dragons or Shadowrun especially, and you just go look at the names on your books, many of them were written by Nigel Findlay. He was a very prolific game writer, and he would just write all day long. He would sit down, he would write for 8 hours. His goal was to write about 5,000 words every day. And so if you wanted an adventure, he would have it to you in less than a week. If you wanted a source book, you'd get it in about 2 weeks. And if you wanted a novel, you would have it in about 6 weeks. And that he just wrote so fast and so consistently. And his advice was really learn to write fast, and then you'll learn to write well. And I've followed that advice. And so I'm a very fast writer. And that just comes from mountains and mountains of practice. Just being able to take the thoughts in your mind and turn them into words on the screen as effortlessly as possible. Writing is always going to be hard. It's always difficult. And, people experience this idea of writer's block. But, like, writing is a job, like any job. And the way you deal with writer's block is you sit down and you write. And it might be garbage, but you write. And then you're not into it, and then you get into it, and then you can't stop. And so that's sort of my advice to being a writer. How you get work in the industry, like if you've written a lot and you can show the work that you've written, you'll have a job anywhere. So my advice is start a blog, start something on Medium, or just start your own website, or start a WordPress website, or go and write really interesting posts on Quora or places where people are going to be able to see your work. And then you can just go to target some magazine or company or website like me and just say, here's my portfolio. Do you need a space writer, or do you need a whatever writer? And if your work is really good, then there's lots of jobs. I get people sending me their resume. I'm like, I don't care about your resume. Like, all I want to see is what have you written? And then I'll be able to get a sense immediately if you're a good writer and if you've got good ideas. And so write a lot. Challenge yourself to write more complicated things. And you can't go wrong. Mike Jones, how do you know that we're not special? Have you been around the galaxy to see all the same Mars and Venuses everywhere to make that claim? So I guess this is a follow-on. This is the advantage of showing up to this live, is people can ask follow-on questions. This idea, the Copernican principle, that we are not special, is just an assumption that just says the only way that we can make any kind of scientific progress about our understanding of the universe is to first assume that we're not special. That star in the sky that we can see is kind of like the sun. And it has the same process going. It has gravity pulling it in. It has light pressure pushing it out. It's made of chemicals left over from the Big Bang, as well as other subsequent star formation. It could have planets that are orbiting around it. And if you go far away, there's a galaxy, and that galaxy is filled with stars. And those stars are experiencing the same kind of gravity that we are here, and all of the electromagnetic forces. And you just have to make that assumption, because if you don't, then you can't understand anything, right? You're like, what's that galaxy made of? And it's made of purple. It's made of yes. And the power of gravity is dream. And you're just like, how do you make any progress? How do you make any kind of scientific understanding? So it's like scientists make that as this base assumption, because any other possibility just leads to crazy town, and like, good luck making any kind of scientific progress. And yet here we are, using the internet and mapping the cosmos and having GPS satellites and exploring the solar system, using this basic assumption that the laws of physics are the laws of physics. And even if you go to Mars, the laws of physics are still going to hold. Liquid Flames. Yeah, I read the super chats, but I don't put any major emphasis on the super chats. But I did happen to like your question, and so I answered it. But just like in general, if people are like hoping to super chat, join my Patreon. Don't super chat. That's why I don't have the membership, because I don't want to have YouTube like be this wall in between me and you as the fans. I want to be able to connect directly. Shalaba Meta. Why a sudden probe rush to L2? Is it due to some new capabilities or new requirements or some other realization? L2 has always been a really exciting place. So let me do this again. All right. So L2, I assume you're talking about the Sun-Earth L2 Lagrange point. And that, of course, is the place that is on the far side of the Earth. And so you've got the Sun, the Earth, and the L2 point. And it's located about 1.5 million kilometers away from the Earth. And that's the place where James Webb has gone. And James Webb, like, it makes a ton of sense, right? Because James Webb has a sun shield. It needs to be maintained cold. And so at L2, it can put up its sun shield, and the Earth, the Sun, and the Moon will all be in the same location, blocked by the sun shield, and it'll be in eternal darkness. And there's been a bunch of other missions, and they all go to the same L2 point for roughly the same reason, which is that if you want to observe most of the sky, then you want to take the Sun, the Earth, and the Moon and hide them in one tiny little corner where they're always going to be there together. And then you get the rest of the sky. The Gaia spacecraft is at L2. So it is just a very useful place to go for astronomy, for space telescopes. But there's been a bunch of observatories that have gone to L2, not just James Webb. And anytime people are going to want to keep the Sun, the Earth, and the Moon clustered together in their field of view, you're going to see a spacecraft going to L2. Starlink is holding up great. I actually answered a big Starlink review at the beginning of the episode, so check that out. Tropical Tom Garcia, when will we be seeing The Expanse on the big screen? I've heard that the plan is to do a follow-on movie to The Expanse, as opposed to bringing back the last, like the unfinished books or the books are finished, but they haven't been turned into a TV show yet. So that would make sense. Kobo Bunny. Kobo Bunny. There might be a good chance for life around M dwarfs if they have large gas giants in the habitable zone with water-bearing Earth-sized moons. Like, is this a question? Like, do I think... All right. We don't know yet. Red dwarfs, M dwarfs, are dangerous little stars. When they first get going in life, they can release flares that are like 100,000 times more powerful than the kinds of flares that the sun throws out. And because these stars are smaller and give off less light, if you want to remain in the habitable zone around them, you have to be really close. You've got this double problem. You've got the stars giving off flares that are up to 100,000 times more deadly, and your planet is tucked in really close to the star, and it's going to take these flares right on the chin time after time. Does a gas giant protect you? And so like a gas giant might be able to generate a very powerful magnetosphere, but it's not going to be protecting the moons. Maybe you've got an Earth-sized moon in the gas giant or orbiting around the gas giant. It's not like the magnetosphere is going to be protecting you. In fact, if anything, the magnetosphere of the gas giant, like Jupiter, is going to cause even more damage. Like, we know that the environment at Europa is quite dangerous because it's in very close to Jupiter. And it's got this very dangerous radiative zones that are going on. So I don't think that being a planet orbiting around a gas giant gives you any special benefit. Maybe if things line up perfectly and you happen to be behind the planet when one of those deadly flares gets blasted and you get protected, then every now and then you get saved, but there's no real special advantage. John Suffill. If our sun was formed in a huge nebula, and if there were several stars formed in the same region, where are those stars now? Those stars, let me do this again. Astronomers assume that the sun formed in a solar nebula, kind of like the other solar nebulas that we see, or stellar nebulas that we see out there, like the Orion Nebula or the Pleiades. And you've got this large cloud of hydrogen gas. It collapses down into multiple stars. Some of the stars explode as supernova, but you get lots of other stars that are smaller. And then over time, the powerful winds blow away all the remaining gas and dust in the region. And then you've just got these stars in this large amalgamation, a star cluster. And then over time, as the star cluster interacts with the other parts of the galaxy, the stars get stripped away. They drift away from this cluster over time until the cluster is completely broken up. And then the stars just turn into this long stream that wraps around the Milky Way. And then some of the stars go higher up the galactic disk, some go lower down, some move inward, some move outward, and so then they just really kind of mix up, and it's really, really hard to tell where those stars are. And astronomers have some candidate stars that they think might have formed in the same solar nebula as the sun. And so the clues they have, one is the velocity and direction of the sun. Like if you had a star that was moving in the complete opposite direction of the sun, that would be super weird. And you wouldn't think that they formed together, but a star that's in a roughly similar trajectory as the sun. And then the other thing is the chemical signatures. So all of the stars that formed in that stellar nebula formed out of the same raw material. And so you would assume that they would all have some version of the same chemistry and would have a very similar fingerprint. We mentioned this earlier in the episode, a chemical fingerprint. And so astronomers have found a couple that look like they have the same chemical fingerprint and also a very similar trajectory to the sun. And it's thought that maybe these stars were once part of the same solar nebula as the sun. Gaurav Sharma, why is the Parker Solar Probe able to survive the sun, but the Venus landers have such short lives? The Parker Solar Probe is designed with a gigantic heat shield to protect it when it moves through the closest point of the sun. And it does it very, very quickly. It's kind of like a comet, and it flies in, does its imaging of the sun moving at a really high velocity, and then flies back out to the top of its orbit, cools down, gets rid of all of that heat, and then comes back down in. And there's a couple of reasons. One is that you're out in space, and so the amount of energy that you're going to be receiving is different when you're out in space than when you're in an atmosphere and you're getting this conductive heat that is permeating your entire spacecraft. Has a very thick radiation shield that it hides behind, and this shield is getting blasted by radiation and heating up, and then it doesn't make it all the way through this heat shield by the point that the spacecraft gets out of the close danger zone. While, say, with the Venus spacecraft, they landed on, it's not like you can have a heat shield against this all-consuming, incredibly hot 450 degree Celsius atmosphere, intense pressure. So it's just really different environments. It may be very hot near the sun, but it's out in space. And so the only way for the heat to build up on your spacecraft is through radiation, and it keeps that shield in front of it. Hopefully we'll be able to see Venus spacecraft last a lot longer than the Veneris did, because I want to learn more about Venus. Flo K. If you had $1 billion at your disposal, what scientific project would you choose to realize? $1 billion isn't very much. Like, to really do work. I think I would, but if I just if I was going to choose a mission in terms of human space exploration, I would add a rotating artificial gravity experiment to the International Space Station or the Deep Space Gateway, or launch something custom in a starship or something like that. Some way to start testing what long-term artificial gravity, with a rotating spaceship would do. Will it provide, does it work? Or will you be sick all the time while you're in this process? Will it help deal with the loss of bone mass and muscle mass with this artificial gravity? What are the long-term implications of being in lunar gravity and in Mars gravity? Because we still don't know the answers to those questions. So I think from a space exploration point of view, that's what I would do. From a astronomy point of view, I would probably go with the sun shield. I'm getting pretty excited about the idea of launching a sun shield. Even a sun shield that can work with ground-based observatories would be pretty great. And it feels like a fairly inexpensive way to add a tremendous amount of capability. Now, I did an interview with John Mather last week, and we talked about this idea. So I'll put a link to that episode, and you can sort of see us working through that idea. But that's what I would probably do. And in terms of scientific exploration, planetary exploration, I really want to see a mission to back out to the outer solar system. I want to see a mission to Neptune or Uranus and to visit the moons. And so I would make that a pretty high priority. We've got some missions going to Venus, but in order to do that, they had to cancel the mission that could have gone to Neptune. And I'd like to see that mission back. you know, because like if there wasn't already a helicopter going to Titan, then I would say Titan, but there is. And so I think what's left to be really explored is the moons of Neptune. Tommy Williams, any news on Alpha Centauri B news? Well, at this point now, oh wait, Alpha Centauri B. No, there's no news. There was like a signal that if that's what you're talking about, they thought there was a signal coming from Alpha Centauri B, and it turned out to be probably coming from Earth. And so the news is that there was nothing. So Fraser wants to probe Uranus again. Yes. I want to send a probe to explore Uranus. David Waka, what's your most controversial opinion in astronomy or in a nerdy subject that you're into? I feel like I have a lot of controversial opinions. Like, I think we're alone in the universe, and I don't think that we're ever going to want to colonize any other planet in the solar system. So I feel like those are pretty controversial. Yeah, I'll go with those. Reed, do you know why Sagittarius A photo hasn't been released? No. It's hard, I think, is the answer. Yeah. It's just that the capturing the image of M87 was a lot easier because it's much farther away, and so the changes in the shape of the black hole are very small, but it's a very dynamic environment, and we're much closer to the one at the center of the Milky Way, and so it was tricky work and a lot of really complicated follow-on processing time. And my understanding is that they're still grinding on it, so stay tuned. Max, would tides be a problem around a habitable moon? It depends on the habitable moon. So I'm sort of imagining you've got, say, a sun-like star, there's a Jupiter-like planet in the habitable zone, and then you've got a Earth-sized world orbiting around that Jupiter as a moon, but it's habitable. So it all depends on whether or not the moon is tidally locked to the planet. So there's multiple moons that are going around the planet. So it all depends on whether the planet is tidally locked to, it all depends on whether the moon is tidally locked to the planet. If the moon is tidally locked, then it's always going to show the exact same face to the planet. And so it won't experience any tides. It'll be no tides. And it's possible that no tides is the problem. You know, many astrobiologists think that, in fact, the fact that Earth had tides early on was one of the reasons why life was able to develop from the ocean and shift over onto the land, because you have creatures living in these tidal areas. They get some air, some water, some air, some water, and they can move up the tide area to be able to live in air longer and longer, and eventually be able to transition up onto land. So no tides might be a problem. But if the planet is orbiting around but if the moon is orbiting around the planet and it is actually turning, then yeah, you'll definitely have tides. But it would become tidally locked almost immediately. So I don't think it would be a problem. Fernando Rodriguez, if you watch Cool Worlds, yeah, absolutely. I've interviewed people from the team many times, so definitely. David Kipping is the person behind Cool Worlds, and if you search David Kipping on my channel, you'll see an interview that we did about some of the research that he's doing. And we've talked on the weekly Space Hangout. Yeah, he's one of my favorite researchers. He's doing a great job. Gallon, wow, can you expand a little on why you think we're alone? Thanks. You're going to have to go back and see some of the previous episodes because I talk about this quite a bit. But I don't know, like, what's the good one where I talk about it. But I do talk about it, it comes up quite a bit. Justin Steger, does Vancouver Island have a community telescope? Not that I know of, like a community one. There was the Royal Dominion Observatory in Victoria, which you could go and they had a telescope there, but I think they shut it down. So I don't know of another place that has a telescope. You have to go to Vancouver. They've got at the planetarium in Vancouver, they've got a telescope there you can use. Tom Gakwa, how would you go out to collect meteorites? There's a lot of the meteorites are found by amateurs here on Earth. And it's pretty tricky to find like a stony meteorite because the stony meteorites look like a rock. And it's really hard to know the difference between a rock and a meteorite. And the best way to do that is to go to a place which is very bland, very similar. A place with lots of sand, like the Sahara Desert or the deserts of Australia. Or a place that's covered in ice and snow, like Antarctica. And then people will travel around looking for anything that is strangely sitting out there that shouldn't be there. If you're driving in Antarctica and you're on this snowy plain and then suddenly you see this rock sitting on the top of the snow, it's a meteorite. It has to be a meteorite. The metal meteorites are a little easier to find. One, because they're just so weird and heavy and feel like a piece of metal, but also you can use a metal detector. And so there are people who go into like large farmers' fields with a metal detector and attempt to detect any kind of metal under the surface. And they'll dig down and what do you know? It's another old Roman coin or piece of garbage from a century ago. But sometimes there'll be meteorites found under the surface. So both are ways that you can go about it. Researchers have actually figured out ways to teach drones to find meteorites. The drones will fly around some landscape and then use their machine learning algorithms to look at various locations and find anything that looks out of the ordinary. And some of them will even retrieve them and grab the meteorite and bring it back to the researchers and drop it in their lap, and then they can decide if they think it is actually a meteorite. So yeah, there's a few ways to do that. There's the guy named Jeff Notkin who runs this TV show called The Meteorite Hunters and talks about all the different techniques that people do to go and find these things. I highly recommend it. It's a great hobby to get into. Definitely check it out. All right, so those were all the questions. Oh yeah, and micrometeorites. Yeah, so John Stoff was mentioning this. You can also find micrometeorites. So you can go and take the material that's falling on your roof, you can collect it up into a bag, like the debris that's coming on your roof. Now, most of it is going to be like pieces of coal or dust that's flown into the air, but you can look through it under a microscope and find particles that look very weird. And there's books that'll help you figure out which ones are meteorites. So it's a cool hobby. I definitely am planning, with the new studio that we're building, it's got a metal roof. And so my goal is to try and see if I can find some meteorite particles that are landing on my roof. But then I also need a microscope. But anyway, I'm definitely gonna get into it. So I'll keep you posted. All right, so stick around. I'm going to. Okay. I'm gonna do some final stuff for the episode, and then we'll get into the. Okay, all right. More questions in a second, but first I'd like to thank our patrons. Andrew Block, Matt Masters, Paul Freeman, Lisa Bradley, and the rest of our members. Let me just again. So I'm having something kind of busted on it, so I'll just fix it. All right. And the rest of our 812 patrons for their generous support. Want our videos early with no ads? Join our community at patreon.com/universetoday. All right, those were all the questions that we had this week. Thank you, everyone, for asking questions both in the YouTube comments throughout the week, but also showing up to the live show to ask your questions. We do the show every Monday at 5 p.m. Pacific time. So if you want to come ask your questions, come and join us. And the next episode should be somewhere around on my channel. I'll try to make sure that the event is set up. All right, we'll see you next week. If you want a single comprehensive resource for space news, you want to subscribe to my weekly email newsletter. Every Friday, I send out a magazine of space news with dozens of stories, pictures, brief highlights, and links so you can find out more. Go to universetoday.com/newsletter to sign up. It's totally free. And did you know that all of my videos are also available in a handy audio podcast format so that you can have the latest episodes as well as special bonus material like interviews with me show up on your audio device? Go to universetoday.com/audio or search for Universe Today on iTunes, Spotify, or wherever you get your podcasts. And I'll put a link in the show notes. Thanks to all the moderators, and a special thanks, as always, to Chad Weber and Nancy Graziano. Okay. And then I will stop the recording, but don't go anywhere. I'll answer your question in a second, William. It just won't be in the live show. Or in the... Okay. It just won't be in the question show. I'll get a drink. Fraser After Dark. So William R. asks, even though you think there's no aliens, don't you think that we'll find a planet that could have life? That could potentially have life? So my sort of chain of reasoning in this is based on the Fermi paradox. And so we don't find life everywhere. We see no evidence. And so that tells us is that there's no intelligent civilizations out there. Again, it's not that we can't see them because they're really far away, that intelligent civilizations could have easily colonized the entire Milky Way, even the solar system. And so the Milky Way, the solar system should be crawling with von Neumann probes, self-replicating themselves and getting into space battles all around us as they compete for territory in the Milky Way. We don't see any of them. So it's like a process of elimination that we're alone in terms of intelligent civilizations. And then I kind of assume that even if you have fairly simple life, like even like bacterial life, that evolutionary pressure should tend towards complexity and eventually intelligence. And so even if you start with bacteria, you end up with octopuses or whatever is the alien equivalent of that. And so it's like, if you have bacteria, then the solar system should be crawling with von Neumann probes. That's the chain of reasoning. And that's obviously the short version of it. Like I could take 2 hours and explain it in gruesome detail, each of the pieces that I, how I get there. But that's the gist of it. And so I just feel like because we don't see von Neumann probes battling in the solar system for domination in the Milky Way, then there are no intelligent civilizations, and there were no other species that evolved to become intelligent civilizations, and there was just no bacteria. So that's my, like I don't know, right? Like nobody knows the answer to this question, but that's just my, that's my rational take as I think about it. But on the flip side, I'm a giant proponent of us trying to figure this out. And so that is my, that's why I both put, like, that's why I want someone to figure this out. I want someone to discover life somewhere out there in the universe. And so then I can drop it, because I would way rather there was life in the universe than not. It's terrible if we're alone in the universe. I hate it, but it's just my thought. Series K. Lee, but maybe the galaxy is a dark forest. No, I don't like the dark forest theory, because we will be able to see other alien civilizations with powerful telescopes, and they can see us to thousands of light years soon. Like, and maybe not like James Webb, or maybe not Super James Webb, but maybe we build an interferometer the size of the Earth's orbit around the sun, or we send out a spacecraft out to 1,000 light years from the sun, and use the sun as a gravitational lens to read newspapers on alien worlds. Like, we will develop the technology to detect the aliens if they're out there, and they can do the same with us. So that's why I don't find the dark forest theory legitimate, because there's plenty of ways to do it. Yeah, as Elon says, humanity itself is not doing very well right now. The Fermi paradox doesn't seem like a paradox to me. Yeah, well, that's the terrifying possibility, is that we're due for a reckoning any day now. Dolphins don't have von Neumann probes, but are they unintelligent? No, for sure. But we kill dolphins because we make tools, and we'll be making von Neumann probes shortly. So you could absolutely have intelligent species, but as long as there is a species that is better equipped to wield weapons and cause damage and go to space, then other intelligent species are going to be ground under the boot of the ones that can. I'm like look how we treat dolphins and whales, right? Like, people eat them, and they're intelligent. Like, just think about that. So, yeah, you kill dolphins, maybe. Don't project on me. Okay, yeah, that's true. That's true. I am assuming that nobody in this chat kills and eats dolphins. We're all against it. But there are definitely people here on planet Earth who you would consider intelligent, who are mean to other intelligent species. Chimpanzees, octopuses, dolphins, parrots. It goes on and on and on. It's just that we've got the bomb, right? That's why we get to call the shots, because we have the ability to exploit the power differential between us and those species. And you would assume that other alien species would have the technological ability to do whatever they want to us. Maybe vengeance for the dolphins. So, no fun. You've been known to punch a whale. Okay, well, there you go. Right? See, you're not a saint. Let's see. Sean Marston, yeah, pigs are one of the most intelligent animals. We eat them every day. Yeah, it's literally no difference between a pig and a dog. SeaTac Delta, any reason why we haven't tried an artificial gravity experiment in orbit? Well, I've got like two answers. One is like, no, I can't think of any reason why we haven't done a artificial gravity. We should. It should be a high priority. But the reality is just that it's complicated, it's expensive, and there hasn't been a gigantic priority to do it yet. Like you want humans to live in space, and I want humans to live in space, or to be able to be on and not have their bodies wear down from the lower gravity. But it just hasn't been that high a priority for NASA and ESA, etc. And so it's just, they're expensive. And, you know, there's been, like, I saw one mission plan that was like $4 billion to attach a rotating module to the space station. So it's just expensive. And just, there's been other higher priority projects, but eventually it will go to the top of the queue. Thoughts on Pokufetes? Thoughts on wormholes? No. I mean, they're an interesting mathematical thing. They make for really great science fiction, and there's no evidence that they exist or can even exist. So, Tropical Tom Garcia, the South Park episode where they launch a whale into space is still among my favorite. So this is a thing. I'm going to reveal a secret that has been going on for like 10 years and nobody's caught it. So might as well tell you. So we snuck a South Park reference into one of our episodes of The Guide to Space a long time ago, where I think it was the one like, what would the Earth look like from the moon? What does the Earth look like from the moon? And we've got some renders of the moon that were done by Kevin Gill. And in that picture, there is a killer whale on the moon that we put in there. And nobody has ever mentioned it in the comments or the chat, ever. So, yeah. So there you go. I give up. Nobody found our Easter egg. And so I had to say it. Red Circle Silver X. Anything specific that you're excited to see from the Jupiter Ice Moons mission? Yeah. So like this is the JUICE mission. This is the one that's being sent by the European Space Agency, and they're going to go to Europa and Ganymede and Callisto, but mainly Ganymede. And like just like Ganymede is what I want to see. I've been mentioning this for a while that Ganymede is like the new Europa. It has higher gravity. It has a magnetosphere, so there's some protection. It's farther away from Jupiter, so it's not experiencing the same amount of radiation as Europa. It has a liquid water ocean underneath a thick ice shell, but it's made, its surface is made of ice. So I think Ganymede is as interesting or more interesting. It's the biggest moon in the solar system. I think it's more interesting than Europa. And so I'm just really excited that Ganymede is finally getting some exposure and some love. So yeah, I'm really into it. Jolly Blonde Giant. Fraser, would you say that sci-fi has to stretch scientific accuracy at least a little bit to tell a good story? Sure, yeah. I'm like, even The Expanse, which I've been a huge fan of, the rocket engines in The Expanse are basically magic, right? The fusion drives that they use to zip around the solar system. We don't have that kind of fusion drive and fuel density or any of that. So, not to mention what happens with the protomolecule. So yeah, I mean, I think that there are, like, when you're doing science fiction, there are stuff that if you kept it scientifically minded, it wouldn't change the story. It's just because you're lazy. Like, you literally just didn't look up the difference between an asteroid and a comet, or how orbital momentum works, or anything like that, right? But then once you've got all those fundamentals down, then it's perfectly fine and reasonable to take a leap, to include some kind of technology that's magic that enables the story to move forward. And so, but I watch a lot of science fiction, and I mainly just turn my brain off and don't think about it. But the stuff that bugs me is when they make a mistake, like a really stupid mistake that they didn't have to make, that they could have just asked someone and said, hey, astronomer, here's my script. Is this all right? And the astronomer goes, oh, no, that's wrong. And they fix it. That's the kind of stuff that bugs me. My wife used to be a respiratory therapist. And so when she sees, like, ventilators put on wrong, she, rolls her eyes. Because, again, like, all you need to do is have a medical consultant look at how you're intubating a person and go, no, that's not how this works. It should look like this. And why not be accurate with that kind of stuff? So, but I don't really worry about it. You could go crazy. Like, when Optimus Prime catches a falling person, right, in his hand, the person would be falling from whatever distance they fell onto metal and would die. Like, you've got to catch them, not just put your arm out and have them hit your metal hand. Things like that. So I don't really worry about it. I just turn my brain off and just enjoy the show. Nancy Graziano from Paul: is there any scientific hypothesis or principle that has not been used as a basis for any element in a sci-fi show or book? No. I can definitively say no, that every idea that's ever been thought of has been written about in some sci-fi book. And I don't know, but every time I'm like, oh, this would be a really cool idea for a story, people tell me 10 books that have that idea in it. So I would assume that most of the really good ideas have been thought through. There's some writers that people keep mentioning that I should read. Making my way through the Ian M. Banks books. There's other books out there and lots of great ideas. So I wish I had more time to read, but I also wish I had more time to play video games and spend time outside. I just need more time. So if anyone can make more time, that'd be helpful. There you go. Optimus Prime used hand moisturizer. Super soft skin. That makes sense. That's how it works. All right. I'm going to wrap things up. I hunger. So thank you, everyone, for hanging out this week. This is going to go in the can, and Chad will get editing, and we should see this in a bit. Thanks to all the moderators. Thanks to Nancy for organizing all of the questions. And thanks to everyone who asked questions and hung around for the chat. All right. We will see you all next week. Thanks, everyone.